All right, so in this section, we are going to solve systems of linear equations of two variables graphically and algebraically. I'm going to break this down into three different videos. All right, so first of all, let's do it graphically. All right, what you want to do, the steps, you want to get your equation in slope-intercept form, y equals mx plus b. You want to graph each equation using y-intercept and slope, using your y-intercept and slope, m and b. If the graphs intersect, the solution is the point of intersection, and they are consistent. If they are parallel, then there is no solution because they never intersect and they're inconsistent. And if it is one line, then there's infinitely many solutions because they're intersecting constantly. It's one on top of the other, and that's a dependent system. Okay, so let's look at some examples. All right, examples, solve the systems of equations graphically. All right, so first of all, what I need to do is make sure my equations are in slope-intercept form. So let's look at this first one. I have 1/2 x plus y equals 3. I need to get that in y equals form. So what I'm going to do is I'm going to subtract 1/2 x from both sides. And I have y equals negative 1/2 x plus 3. Oh, I don't know what I was getting ready to write. Plus 3. Okay, so what I need to do, and I'm going to keep this in green, is I need to graph my y-intercept, which is 3. So I'm going to go up 3, 1, 2, 3. And from there, I'm going to graph my slope. It's negative, so I'm going to go down and right. So down 1, right 2. 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 Okay, and if I could go down and right, I can also go up and left. So I'm going to go up 1, left 2. 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 All right, and now I'm going to cheat a little bit and use my line drawer. Okay, so that is my line. All right, and I'm just going to keep all that green. So now let's go to my second equation. Okay, so for my second equation, well, it's not going on pen. My second equation, I have negative 3/4 x equals negative 2. And I'm just going to keep this in red so we'll be able to see everything. So I'm going to add 3/4 x from both sides. And I end up with y equals 3/4 x minus 2. And if you need some instructions on how to graph the lines, be sure to refer back to our previous videos. So my y-intercept is negative 2, so I'm going to go down 2. My slope is positive 3/4, so that means I'm going to rise 3. 1, 2, 3, run 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. And then 1, 2, 3, and I can't go anymore. So I mean, if I could go up and right, I can also go down and left. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, and 4. Now I'm going to connect those dots. I'm going to draw my line. So let's make that red as well. Come on. Okay. I keep losing my mouse. I'm not sure where I'm going. Okay. Oh my goodness. There we go. I don't know what happened, but my computer was doing something a little kooky. All right, so now our solution is the point where they intersect. So at what point do these two lines intersect. The intersection is right here. So that right there is my solution. So it's 1, 2, 3, 4 up 1. So my solution is 4, 1. Okay, now for B, let's look at that one. For B, the same thing. We're going to solve the equation for y. So I have 2x plus y is equal to 4. Okay, subtract 2x. And my equation is y equals negative 2x plus 4. Now to graph that equation, graph your y-intercept first. So that's going to be 4. And from that point, my slope is negative 2. So that means I go down, since it's negative, down 2, 1, 2, right 1. Down 2, 1, 2, right 1. 1, 2, right 1. 1, 2, right 1. And I like to cover my whole graph with this line. 1, 2, right 1, because you never know where they're going to intersect. So I'd rather be proactive. So if I can go down and right, I can also go up and left. So 1, 2, over 1. 1, 2, over 1, 1, 2, over 1. Now, connecting those points. Going to change that to purple as well. All right. Okay, so now for my second equation. And let's make it pretty blue. I have y equals negative 2x minus 5. Well, that's already in slope-intercept form. Okay, so I'm going to go down 5, and my slope is negative 2. Remember that negative 2 is over 1, so I'm going to go down 2, right 1. Down 2, right 1. That's as far down as I could go. If I could go down and right, I could go up 2, left 1. 1, 2, left 1, 1, 2, left 1, 1, 2, left 1. All right. So, looking at those two lines, what can you tell me is going on? Do you notice anything? Okay, those lines are parallel. So what does it mean for the lines to be parallel? If you can't remember, refer back. Let's go up here. Parallel lines, no solution, they're inconsistent. So there is no solution and they are inconsistent. So let's write that here. No solution. They're inconsistent. Let's put parallel. Okay, good job. So let's look down here at C. Okay, so same thing. We're going to make sure we have them in slope-intercept form. Y equals mx plus b. So C is x minus 3y equals negative 6. That did not change colors for me. All right, so I'm going to subtract x, negative 3y equals negative x minus 6. Divide every single term by negative 3, and I get y equals negative over negative is positive 1/3 x. Negative divided by negative is plus 2. So my y-intercept is 2, and I'm going to graph using my slope. Rise 1, 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. If I could go down, up and right, I can also go down and left. 1, 2, 3. Okay, then now let's connect those points. La la la, connect the dots. Yeah, I always love saying that. Okay, so that's my first equation. Now let's look at the second one. Okay, for my second equation, I have y equals 1/3 x plus 2. Uh-oh. What do you guys notice about these two equations? They're the exact same, so I'm going to have the same line. It's going to be the exact same. Same point, same everything. Okay, they're the same line. So the answer is infinitely many solutions. And can you remember what that is? If not, what do? You refer back up here. So that is dependent. It's a dependent system. All right. I'm just doing that because I want you to know you can do it. All right. Now for example D. Okay. Is the ordered pair 2, 1 the solution to the system? Well, when you're given something like this, all you need to do is plug it in. Okay. So let's plug it in and see if that is a solution to the answer. Solution to that system. So 3 times 2 minus 1 equals 5. Let's see if that balances. Okay. 6 minus 1 is 5. 5 equals 5. But we're not done yet. You need to do it in both equations. Okay. So now we're going to check the second equation. It works in the first equation. So now let's check the second. So we have x2 plus 1 equals 3. 3 equals 3. So yes, that is a solution. Yes, 2, 1 is a solution. Yay, and I'll put a smiley face here for you. All right, well, thank you for watching.